to Enots Engineering. I'm Alan. Today we'll be making an expanding mandrel which fits on the lathe headstock so you can turn the chuck using a handle. This is particularly useful when you're turning a thread and you're coming up to a face. With the Boxford, when you switch the motor off, the chuck carries on rotating for 2 or 3 times, so you have to judge. With this mandrel in the headstock, you can fit a handle so you can stop the motor and turn the headstock so that the cutting tool comes up to the face without smashing into it. So let's see how we make it. First thing I've done is put the 4-jaw chuck back on. It's clocked it up as true as it can go. So the first job is to turn it down to length. I need it 70mm length. $29.69. I've turned it down to the headstock size of 20.5mm. Set my boring tool up to centre height. I've changed the angle to 8 degrees. I've set my small boring bar up, and what I've done is I've zeroed my carriage, my cross slide there, so I'm not going to come any further out than that. And the red mark is the depth I want to go in before I start to cut. So I'm just going to go in, start cutting there, and go forward as far as I can, and then come back to that mark. So now it's in the bore. I'm just going to set a stop on the bed. That's the furthest I'll come back now, because as I hit the stop, it's there. I can only go in that far. So what I'm going to do is bore that out until I get to my 0 reading, the full depth, and back to there. I've bored the bore bigger from there to there, and I've left the taper at the beginning, which is set at 8 degrees from there to there. But the basic principle is that I've thinned the wall down here so it should spring open easier when the cone is pulled through. I've just turned it round in the chuck, clocked it up off the part I turned earlier. So all I'm going to do now is just to get a nice, or a better finish than that, and face the end. already got a counterbore on here from the last job I did, so I'm leaving that on, but to make sure it's running true in the centre, I'm going to centre drill it again, because this bore here might not be true to what I've just turned. It's a 7.5mm drill which I used on the other side, so that should meet up with the one that I've already drilled in. That's the hole straight through. Now what I'm going to use for my bolt to pull the cone in is this, which is a cylinder head bolt, so it should be quite good steel. The only problem is it's got an 8mm thread on the end and a 7mm diameter, so it won't go in yet. And what I want to do with this is, because I think the thread's a bit coarse, it's a 1.5mm pitch, I want to make 6mm thread. I think I'll use a standard 1mm pitch, so it'll be a finer thread, so I can, as I'm tightening this up, it will pull it in a smaller amount. So what I want to do as well is put a cone in this end, so that when this goes in, it will centralise on this end and pull the cone in that I've got on the other end into the bore. Because I don't know the exact angle on the cylinder head bolt, I'm going to guess here at 30 degrees, turn a portion at 30 degrees and then see how it fits. Just put a slight amount of micrometer blue on. Push it in. Yeah, you can see now that's just touching on the outside edge, so I need to alter my angle. It's at 30 at the moment, so I'll just bring it to, it's probably about 31 degrees. You've got spots all over that, so it looks as if it's okay at that angle. I'll just take some more off so this goes in a little bit deeper. Having checked the length of the bolt and compared it to the length of the metal, with the taper at this end, this bolt doesn't come out far enough. So what I've done is exactly the same as you've seen me do before, but I've just moved it 20mm down the bore, put the 30-degree chamfer on the end so that the bolt goes 20mm further down. So this is what we've got so far. We've done the taper for the cone. We've put an undercut in to make the wall thickness here thinner so that this will flex easier. We've drilled the hole straight through for the bolt. We've put the cone or the chamfer there for the bolt head. Remember, we've moved it from the front further back, so the length of the bolt will go from there to the end of the bar. Now the next job is to machine this bore to size, and we have to make this part to go on the end and the cone. Now I find a good tip is use a piece of white plastic and put it under just on the carriage,
So when you're moving your tool towards the diameter you want to cut, you can actually see the gap that's left clearer than without having the plastic. You can see the gap between the tool and the part. Just break the corner, take the sharp edge off it. If I go over what we've done, we've machined the bore, we've put a taper on the end of the bore that the Allen screw will hold onto, so that goes into there. The thread just comes to the end of the bore, so that gives us the correct length. This wants turning down with a 6mm thread putting on it, but this part's finished except for the slotting. The problem we have with the Boxford lathe is that you've got this door on the end of your gears, so this is interlocked to the power, so every time you open the door it cuts the power. Now it would be nice to be able to put the handle on there with the door open, but because this door's there, we can't do that without altering the wiring. So with this shut, you need to put the handle through this side. So this will be permanently fitted there, but then the problem is if you want to use or change your gears, you can't open the door because it locks up, it fouls up on the door. Okay, I've changed the chuck for a 3-jaw chuck. I've got some hexagon steel, and I'm going to face the face off and reduce the diameter so that it fits inside the bore. So I need to come about 1 inch long, reducing the diameter to fit that bore. That's 20. All I need to do now is turn this round and put a nice, face it off and put a nice dome on the end. I'll turn that round, put a countersink in the other end. with a countersink in that end. The other end holes through. That should fit into this end. Shaft here is 7mm. That was 8mm, but I want to put a 6mm thread along here, so I'll turn it down to 6mm. Now I'll just angle the tool a bit just so I can put a slight lead on the beginning. In this die holder I made, basically you've got a number 2 Morse taper that fits into your tailstock, a parallel piece of steel as a guide. This then runs along this parallel piece and holds a die in this end with a handle. What you can do is put your chuck key in as one handle and use the other handle to turn the die. And on the beans it's still on the bar, that guides it square. So it's just a standard die. This has just got one screw that goes in to locate in the groove, and then it moves backwards and forwards on the tailstock. You can do a thread up to about 1.5 inches and be relatively square. So there's the bolt finished. 6mm thread on the end. Tap that in. Just tapping the 5mm hole into the 2 holes that I've just drilled. So there we've got 5mm grub screw in that side and a 5mm grub screw in that side, and the hole through the centre is still clear. I've put a piece of steel in the lathe and basically drilled and tapped with a 6mm thread through the centre, faced it off, machined the angle, which was 8 degrees, and then just machined a plain part back to clear up the bar. I've put some blue on the angle to match it up with the angle I've already machined, as you can see. So now it's ready for parting off, and that will form the cone. All I need to do now is just clear up the back. and then I'm just drilling straight through. This is a 3mm drill. We have 4 holes now, and all I'm going to do is put a slot down there. I haven't got a slit saw narrow enough, but I think I could just put a saw cut straight down to each hole, and this is finished. So what I'm doing, I'm lining the hole up with the length of the body, marking the saw cut there, and just sawing down, filing off the rough edge. So the other 3 exactly the same way. I've just fitted the arbor in there. You just take a socket wrench and a socket that fits your hexagon. If you don't want to put a hexagon on, you can always put a square hole in the end and use your socket in the end, or make a different handle. But with this, the idea of this is if you put that on there, you can turn the head round, no trouble. You can get, you've got that switched on. Gives you a warning before it comes off, but it doesn't fly around. That's only if you've got the ratchet the right way. If you've got the ratchet set the other way to reverse it, then it will spin round. But that's a bit of a safety device really, because I know I'm going to forget that's on the end. Do my screw cutting, switch it on. But that gives you the option of using different handles. You could use the ratchet, you could use a straight bar, Tommy bar, whatever you want on the end of that. Even a spanner. So you can always change the end for a different size because it's not fixed. On this direction you can see handle goes on there. You can turn the lathe. Because it's quite a wide lathe, it's not a mini lathe, Boxford, it's quite wide here, so you can't really stand over the back and look at the front. So this is useful that you can do it like this. You can, if I put the, engage the gears, so as you can see, turns the chuck quite easily, no effort on that. But to remove it, you just take the socket off the end, get your own key down the hole, spanner on the end, or you can hold the chuck, slacken it off a couple of turns, take it out. Well, I hope you've enjoyed it, and I hope to see you next time on Enots Engineering.